There's an operating system running pretty much our entire world that's basically hidden in plain sight. Nope, it's not Windows and it's not macOS. It's the invisible engine behind almost all of modern technology, and I'd bet you've used it dozens of times today without even realizing it.
So let me ask you a question. What on earth could possibly connect NASA's Curiosity Rover driving around on Mars, a SpaceX Falcon 9 rocket blasting off into orbit, and the incredible special effects you see in the biggest blockbuster movies? I mean, they seem like they're from completely different universes, but they all share one single, absolutely critical piece of tech at their core.
The answer is Linux. And look, it's not just for spaceships and Hollywood magic. That Android phone in your pocket, the heart of it is the Linux kernel. The flight software in a commercial airliner, the MRI machine at the hospital that could save your life, pretty much every website you visit, even the mind-blowing visual effects for the Marvel movies, all of it is built on Linux. It is absolutely everywhere.
So, the big question is why? Why do the most demanding, high-stakes industries on the planet trust Linux for jobs where failure could be, well, catastrophic? It really all boils down to three things: reliability, power, and cost.
All right, let's just put it head-to-head. On one side, you've got Linux. It is legendary for its stability. We're talking systems that can run for years without a single reboot. It's open source, which means anyone can tweak it to be perfect for a specific job. And maybe best of all, it's free. Then on the other side, you have the systems we use on our desktops. You know the drill. They're prone to that dreaded blue screen of death. They're always bugging us with disruptive updates, and they lock you into really expensive licenses or hardware.
So when you boil it all down for these supercritical systems, it's all about these three huge advantages. First, you have that rock-solid reliability, for when failure is just not an option. Second, something called real-time processing. This is what guarantees that a crucial task, like say deploying a car's airbag, happens on an absolutely strict, unmissable deadline. And third, the cost. Being open source literally saves companies like SpaceX and NASA millions and millions of dollars.
To really, truly get why Linux is so special, we have to pop the hood and look at its core, its engine. We need to talk about the kernel. So what in the world is a kernel? Well, in the simplest terms, it's the master controller. It's the core piece of software that acts as the bridge between your computer's physical hardware, like the CPU and memory, and all the ops you're trying to run. It manages every single thing. Now, the Linux kernel is a specific type called a monolithic kernel. And this analogy here is just perfect. Imagine a gigantic restaurant where the chef, all the waiters, and the cashiers are working side by side in one massive kitchen. Everything is incredibly fast because communication is instant. But what's the downside? If just one person messes up, the entire kitchen can grind to a halt. Okay, now let's flip that on its head and look at a microkernel. Think of this more like a modern food delivery app. The kernel is just the restaurant. Its only job is to cook the food. Everything else, like taking orders or making deliveries, is handled by separate drivers. This setup is way more stable because a problem with one driver won't shut down the whole kitchen. But all that back and forth communication makes things a little bit slower.
And this table just lays it all out so clearly. You can see Linux, with its monolithic design, is all about raw speed. At the other end, microkernels give you that amazing stability. And then you have hybrid kernels, like what's in Windows and macOS, that try to find a happy medium. At the end of the day, Linux is betting everything on maximum speed and efficiency.
Okay, so we've talked about the engine. Now let's talk about how you drive this thing. Most of us are used to interacting with computers by clicking on icons and dragging windows around. But Linux's real power, it comes from somewhere much more direct. On the left, you see what we're all used to, right? A graphical user interface, a GUI, with all its icons and windows. But on the right, that is the heart and soul of Linux, the command line interface, or CLI. It's just text, no fluff. And yeah, it might look a little intimidating, but this is where all the incredible power comes from. You might be thinking, why would anyone give up beautiful graphics for a black screen with text? The answer is simple. It's like using a surgical scalpel instead of a butter knife. The command line is faster, it gives you way more control, and it uses a tiny fraction of the computer's resources. That efficiency is exactly why Linux can run on anything from a massive supercomputer to a tiny little sensor. Okay, but how do you actually use it? I promise, it's way more logical than it looks. Let's just walk through a complete, simple workflow together, from start to finish.
We're basically going to tell a complete story with just 4 commands. We're going to make a new folder for a project. We're going to jump inside that folder. We'll create a new file in there. And then, when we're all done, we'll clean everything up. Creation to deletion, all with just a few taps on the keyboard.
All right, step 1, you need a place to work, so you make a directory. The command is mkidr. It literally just stands for make directory, and it does exactly that. Boom! You just created a new folder without ever touching your mouse.
Now that folder exists, but you're not in it yet. To go inside, you use the command cd. That's for change directory. Honestly, just think of it as the command line version of double-clicking a folder to open it. And now, you're inside your new workspace.
Okay, so you're in the right place. How do you make a file? It's almost too easy. The command is touch. You just type touch, give it a file name, hit enter, and poof, a new empty file is instantly created. No file new, no clicking around in menus, just pure instant action. And when your project is finished, it's time to tidy up. The command rm-r will remove the directory and everything inside it. That little -r stands for recursive, which is just a fancy way of saying delete the folder and everything in it. And just like that, your workspace is totally clean.
Now, this brings us to a command that you have to treat with a ton of respect. rm-rf*. This is the superpowered version. It basically means recursively and forcefully remove everything. It will not ask you if you're sure. It won't pause. It will simply and instantly vaporize everything in your current location.
And that really gets to the core philosophy here. The command line gives you direct, unfiltered, incredible power over your machine, but it trusts you. It assumes you know what you're doing. There is no recycle bin to save you. There's no undo button. It really is that classic saying, right? With great power comes great responsibility.
So there you have it. We've pulled back the curtain on the operating system that is quietly and literally running our modern world, from the phone in your hand to the rovers on Mars. You've seen why it's trusted for the most important jobs on the planet, and you've even taken your first steps on its most powerful tool. So now that you've seen the secret OS that runs the world, the only real question is, what are you going to build with it?